Hello everyone and welcome to Fresh Concrete. This is one of a series of talks that's been created to share just some of the wide-ranging innovation practices and new types of concrete emerging to address climate change. So those are technologies that bring a fresh approach and fresh thinking to the way that we make and use concrete. My name is Elaine Toogood. I am Director of Architecture and Sustainable Design at the Concrete Centre, and I'm going to be introducing today's presentation, produced as a collaboration between the Concrete Centre and the Building Centre. So I'm sure you already know concrete is a very versatile material. It's very many potential uses within the built environment, developed to meet our needs, whether they're below ground, above ground, for water storage, on a roof, for structure, infrastructure. And we've seen elsewhere in the series how there are many examples of concrete that's being manufactured differently to reduce its embodied carbon emissions, new construction techniques for greater resource efficiency, all enabling concrete to have a better and improved performance credentials, but to perform in the ways that we would expect it. So for durability, for fire resistance, strength, acoustic separation, for example. But of course, as new recipes evolve and develop and manufacturing techniques change, so do the potential properties of the concrete. And in doing so, providing new opportunities and new potential ways in which it could or can be used. So for example, ultra high performance concrete, that's load bearing concrete, fiber reinforced, that has properties of increasingly ductile. So it has ductility, which you don't normally expect to see from concrete. And in those ultra thin sections, they then offer potential for some really different forms and uses, an aesthetic that you wouldn't naturally associate with more traditional forms of concrete. Or, for example, embedded glass or polycarbonate cast into the mix of the concrete, allowing for light transmittance, so for light to be able to pass through that concrete. Or permeable concrete that can help water flow through the concrete to help reduce surface water flooding, but still act as a paving, or to be able to let the water to pass through, and the ability for them to provide some additional cooling. Or also photoluminescent aggregate in the mix that can glow in the dark. There's also concrete that's been developed to help remove pollution from the atmosphere, used here in the Milano Expo on this beautiful building a few years ago. And a more recent innovation that's being developed in Lancaster University is concrete that's able to store energy, so act a little bit like a smart battery. Now, today's presentation falls a little bit into that last category. It's concrete developed in response to the different ways in which we are creating and using electricity and energy around the built environment. And with that, I am delighted to welcome Mauricio Esguerra, co-founder and CEO of Magment. And he is going to be talking about a new form of concrete that can be used to recharge electric vehicles while in motion. So over to you, Mauricio.
Thanks so much, Elaine. I'm very happy to be here. So I will share my screen now, and very much look forward to your questions, to any comments you may have. As Elaine said, if you just the Q&A section of this platform. So welcome from Munich. That's where we started our company 7 years ago, based on innovation, which is concrete with magnetic properties. Throughout the presentation, I hope you will understand better what this is meant about. But just to start off, I would like to give you the reasons for developing and bringing this technology to applications. So we are looking really forward to support wireless charging for all sorts of vehicles in order to, number one, reduce the dependency on batteries. So that means that you eliminate virtually the need for charging stations. Vehicles should move mostly as they park or as they move on a road or on a highway. And if you consider this not just for cars, but also for industrial vehicles such as forklifts, you could, of course, reduce the idle time. So you would have really 24-hour operation in a factory, for example, eliminate the need for redundant equipment. So there is a lot of savings here. Also, in terms of batteries, because if you can charge continuously, you don't need to have these large batteries anymore. So all of this obviously needs to be cost efficient. And the reason that we are using concrete, even in this magnetic fashion, of course, is addressing the high scalability and the very low cost of the installation of this infrastructure. There is optimal safety. Happy to discuss that because we are really very much following every single standard required in all these charging infrastructures. And last but not least, what we are doing here is contributing enormously to decarbonization, the reduction of CO2 by two facts. One is all of our material base is recycled, which I'm happy to explain in more detail in a moment. But also, the more you enable this technology, the less batteries you need, which is one of the downturns of electrification. So less batteries, lighter batteries is definitely a very important goal in the migration to electrified transportation. Let me tell you now the kind of applications we're addressing, and of course, the kind of problems that we are solving with this. Here in the upper side, you see what you can call the current situation, where you have charging with cables with very high cost of the equipment, especially the batteries, and of course, limited performance, mainly the well-known issue about range anxiety. So those are really things that need to be addressed properly. And obviously, always keeping in mind the CO2 footprint of any solution that we deploy. With our solutions, and this is just in contrast, while you have a forklift moving in on a factory floor, or scooters parking and charging as they do, or roadways with lanes that allow vehicles with low charge to charge up, or even cabs just waiting on the line and the passengers come, or buses for this matter. So all these applications really can be solved by this technology that really brings charge to the vehicles. So we are, to a certain extent, we are changing the paradigm so that it will not be necessary anymore to go to a charging station to abandon the journey just to get the charge. Charge comes to the vehicle. We have had a lot of work behind this. I just want to explain in simple words. This concrete is based of cement with aggregates that are fine and coarse ground ferrite cores. Ferrite cores are ceramic materials that are used throughout electronics, and there is a lot of scrap material coming from the production of these cores, but also a lot of material after its use in the form of e-waste. And this is the kind of material that is being used as cores. I just want to show it here. Cores that are being used in inductors like this one. So this is something I think everybody has seen. So we just collect this, and by crushing it adequately and mixing it in a high dense type of concrete, we make this material for the use of mainly casting components that actually are built in a way, as shown here, that the coil that is required to generate the magnetic field for the transmission is already fully embedded in the part. Just as you see in contrast, the older technologies that have been used so far for wireless charging are coils like the one shown here, either with no magnetic material whatsoever, or using ferrite tiles. So the same material we use as aggregates, but in the shape of tiles, which is very brittle and unfit for road integration. And of course, as a solution, not scalable and very costly. So we are really enabling wireless charging, to put it in simple words, by virtue of the use of concrete with all the scalability, all the local production that allows concrete, as we all know, with minimized copper, with a very long lifetime, and of course, fully integrable in floors and roads. As I assume that in this audience, there are experts that are aware of concrete properties, let me tell you that we have managed to get not only a very high magnetic performance of this material, but also very high mechanical all the way to thermal properties. So we consider this material to be an ultra high performance concrete, so very high compressive strength. And all this is, of course, a necessity in order to make this application work in a proper manner. You see here that we have 3 products that we are bringing to the market. The MacDock, which is wireless charging stations for scooters, e-bikes, and similar vehicles. Then we have the MacCharge, which is the systems that are integrated on roadways, and the MacTrack, which is integrated in factories or in warehouses for the use of industrial vehicles and robots. And as you can imagine, this kind of integration needs to be contrasted to what is being used today. And of course, a number of advantages must be highlighted in order for whoever would be interested to see that there is a justification to adopt this. So number one thing which is essential to stress is that we are talking here about true dynamic wireless charging, meaning that the vehicle, no matter where it stands, no matter where it's moving, will always have a charge at a very high transmission efficiency in the range of up to 95%. So that means that this increases the safety and reduces the maintenance needs. So there is no open contactors, there is no risk of sparks during charging, which has been one of the problems since the adoption of electrified vehicles, going away from combustion vehicles. So we are, to a certain extent, with this technology, coming back to the convenience of combustion vehicles without all the obvious disadvantages. Another point which is very important to state is that there is no need for peak power, because this continuous charging allows these installations to go with very modest power ratings around the factories. And of course, reduce real estate. You just integrate everything under the floor, so there is no need for special areas. So all these things, if you sum them up, turn out into a true business case for the users. However, let me go a bit into more details about how this is really implemented. This product that I mentioned before, the MacDock, which is being used for micromobility, is already a product that we are producing industrially. So we are already doing this with a precasting facility here in Germany, producing this in the hundreds, and allowing this to become the preferred option for charging this type of vehicles. We do provide the corresponding receiver kits to the vehicles, to the scooters, so that with the charging station and the receivers, you have a kit that can be used easily in any sort of operation. Important to stress one point here in general is the fact that wireless charging has been already standardized. There is some continuing work to implement different and advanced applications. But the good news here is that wireless charging goes by a single universal standard worldwide. So our mission is not to generate special types of systems. On the contrary, we want to support the standards. We're very active in the standard committees and have our technology ready to really embody the standards in a practical manner. So we do not have to worry, therefore, in most cases about the receivers. If we provide them just as a bundle solution, it's just to promote the commercial implementation, but the interoperability to any sort of vehicle that is also following the standard is given from scratch. One important point here about future uses, I mean, you just saw about the forklifts and about the scooters, is of course the much more comprehensive and more aggressive program of roadway electrification. There has been a lot of discussion about this lately, but at the end of the day, we really need to prove that this is at all possible. So the first project worldwide with wireless concrete highway is being deployed currently in cooperation with the Indiana Department of Transport and Purdue University, all based on our technology. And this is supported by an American entity called Aspire, which is funded by the American federal government. And this has created actually two very important items in the solution of the electrification of transportation. One is, of course, to generate the interest from Department of Transport all around the United States, but also abroad. And this has allowed us to really interact currently with different states in order to continue the work we started here in Indiana. And number two, very important, is to really show that a highway with this kind of electrification would support the use of electrical vehicles. So this is really targeted at people to really be encouraged to go for electric vehicles. So this is quite relevant and important. Two more projects we are involved in, both in Germany, are the integration of an infrastructure for the use of an autonomous minibus, which is solar driven. So this way, this would become a fully autonomous system, including the charge. And the other project we're working on with one of the largest road construction companies worldwide, which is Strabag, involves the construction of a new all-concrete highway using a two-layer machine-assisted concrete construction method. So these kind of things, these three projects, will definitely prove the concept of road electrification and open the door for future applications. And obviously, expecting the vehicle companies to actively support and participate. There has been, of course, a lot of press around this recently in the New York Times. There's a lot of press around this, but I think it's important to understand that beyond all this hype and beyond all this technological emotions around this, this is a kind of technology that has something which is much more important, which is the possibility to monetize it in order to deliver a service. So we have here, and I hope video can be seen. I hope that works now. We have here a cooperation with Ferrovial, which is a company in the field of payment of toll roads and the like, and they have developed a blockchain-based system which allows the vehicles to pay as they move and as they charge. And this is, of course, a condition for getting such a road to become a really monetizable infrastructure. So you can see here this short video showing how the vehicle moving along the road with the installed infrastructure, those are the codes, can pick up charge So the vehicle goes now to the right lane, picks up charge and pays for the service. as it moves and as it charges. But also because of the bidirectional feature of the system, it can also deliver charge to the grid, so it can sell energy to the grid. So going back to our presentation, because we are coming already to an end, I think it's quite clear that the use of this type of concrete has a lot of possibilities. I mean, we have seen this also in various fields, but one last point I want to mention here, also the possibility to use this to build up charging as a service devices that can be integrated similar as it's being done today with lighting as a service in factories. So you could integrate in the floor, so that this is something that is catching the attention of energy companies that are desperately looking for new possibilities to sell energy. And this is one of the options that are being considered. So I would like to thank you for your attention. I just would like to finalize this talk by stressing one very important point. Holcim is our strategic cooperation partner. This agreement was announced beginning of the year. So we are really getting to very high performance grades and technologies that allows us to really go into the market. And I would say that if you have any questions, it's a good moment for me to stop the presentation and be ready to use the remainder of the time to answer those. Thank you very much for your attention.
Thank you very much, Mauricio. I'm just going to get my... Okay, excellent. Thank you. Really excellent. And we have got a few questions here that I'm going to just see if I can tap into. One of them is fascinating. Who would have thought that concrete could be used potentially to sell energy or electricity, which is what your final points were saying. But yeah, fascinating. So we've got a few questions. One was asking about, you mentioned scooters there. Is there any potential for charging electric cycles, so bicycles?
Absolutely, of course.
Yeah.
Yes.
I guess it's about the size of the equipment that's needed on the moving part. Is that right?
Correct. I mean, it's valid for any vehicle. You, of course, have to find a good way to integrate the receivers, to find the right location for the transmitters. But we have done already kind of very nice designs for bikes as well. Okay, excellent. And so we've got a range of different questions here. There's one which I'm sure you get a lot, is to do with the impact of the magnetic field. Is, if this is, mass adaptation of that, is there any environmental impacts with regards to the magnetic field that it's providing? Okay, that's a very good question. Of course, that's one of the areas where this new industry and us pay a lot of attention. Basically, because of the presence of the magnetic concrete, you do reduce severely the stray fields, so that most of the fields stay just below the vehicle. And in case that somebody or something would be in between the coils, this would be detected and would yield a switch off of the system. This is required by the standards, so there is no safety hazards involved. Okay, good. I didn't expect there to be any other answer than that, because I wouldn't have thought you'd have managed to get there this far if there was. But it is, as you say, I can imagine that being a particular concern. So just to clarify, these are always precast units. I'd anticipated that the precast units that are then fitted below the road surface. Is that the main? That's what the yes. So right now we are going preferably by precasting and installing precasted components. But as you saw, the project with Strabag will allow us to also try this in situ casting. So that's also possible. Workability of the material is excellent, so there's no restrictions to doing so.
Okay, so that ties into a couple of other questions we've got here. So one is to do with the weathering of the units, or does the weather adversely affect the capability or the efficiency of the system? And I guess that would determine by whether it's covered and protected as well. So that's the first part of that question. Do you want to?
Well, as a matter of fact, efficiency is a goal, it's not a condition. So you can get to, I mean, of course, not 100%, that is of course not possible, but very close. If you make a proper design, including the size of the component, the way that the coil looks like. So that's exactly our expertise, to reach to the highest possible performance. And of course, under very harsh conditions, because obviously magnetic fields are transparent to snow, water, dust, whatever that is. So that's why this is such a easy to use, fully maintenance-free type of installation.
Okay, and then in terms of its durability, because of if it's in a road with regards to weight of vehicles, different climatic conditions and temperatures, does that impact on the durability or the effectiveness?
Well, obviously, the expectation and the tests done so far point at a very high durability. We are doing accelerated aging tests to validate this. And as far as we can tell so far, so we are talking about 30 or more years of durability without having to do any type of maintenance or anything to keep it going. Quite clearly, climatic conditions play a role. This is why our project in Indiana is so important, because this is a region where you have very hot, humid summers and very cold winters. So that's why we want to see after 1 or 2 years how that really went in the practical case.
Yeah, because there'll be, so the use of it inside in a warehouse is going to have, obviously, that's very much more of a sheltered condition, isn't it? I can imagine that actually the challenges of just all those normal challenges of durability and maintenance of roads is something that you'll need to be testing and establishing. So, for example, de-icing salts, you know, the impact of that, or of course, when often air-entrained mixes or special concrete mixes are used for that sort of type of infrastructure. Has it been tested with regards to those specific issues for road construction?
And I have to say that it's not that critical as it sounds, because we are, of course, in the lower region of the infrastructure. So there is always a good amount of topping on the infrastructure, of the electric infrastructure. And of course, we count here on the vast experience of our cement and concrete and construction partners that have found the right way to integrate this in the way that secures that this is being used. Still, we are going to do tests with variety of sensors, of thermal, mechanical stress sensors, whatever that is, to make sure that we understand everything. And it can be that we need to do some improvements quite clearly, but there is nothing of principal concern. I think it's if you wish, a more normal type of final engineering to bring it really to a proper use in a conventional market.
Brilliant, thank you. There's so many questions here. Unfortunately, we're not going to have time to go through them all. So hopefully you'll be able to answer some of these directly to people who have asked the questions. The final one I wanted to ask was just a time frame in terms of how likely do you think, or how quickly do you think this is going to be available in the roads or the buildings that we have around us? The sort of time frame for deployment, scalability, $1 million question.
Right? It's the crystal ball question. And I would like to give you the best answer I have for this, and is we are starting with small, so the scooter stations are already in use. If you would come to Germany, you will see in hotel lobbies all around. They're being used already. It's small, but it's the beginning. In warehousing, we expect this to be really used in about 2 to 3 years. That's what we're working on. And all uses for heavy-duty vehicles, cars and the like, of course, requiring the vehicles to be electrified, which is still happening. So it's not, so we are kind of in parallel to electrification of vehicles. That should happen, I would say, by the end of say 2028, 2029, around that time. So that's the time frame we see on a more or less realistic outlook. There may be, of course, lucky circumstances that may accelerate this, but on a normal pace, this would be the timeline.
Fantastic. Well, thank you very much. Really interesting. And I really look forward to finding out more about this
Thank you so
technology.
much. And thanks for the questions. If somebody wants to forward the question per email, we're happy to answer those. And one more thing, in case somebody is interested, we are hiring. So people interested in working with us, welcome also to let us know your interest about. Thank you.
So thank you for all of those questions, and thanks again to Mauricio for an excellent talk. Please do look out for other recordings of innovations featured in this Fresh Concrete series on the Building Centre and the Concrete Centre websites. Thank you.